So in this example, the ages of 23 applicants who were unsuccessful in winning promotion has a mean of 47 and a standard deviation of 7.2. Assume that the sample is a simple random sample and find a 95% confidence interval for the average age. So the problem is asking us to create a 95% confidence interval, and it's for the average. So far we know that we have two options for the average if we're doing a confidence interval. One of them is for when the population standard deviation is known. The other one is for when the population standard deviation is unknown. So far we know we have the mean minus the margin of error, and then the mean plus the margin of error. This is part of the formula we're going to use. Or you could write it as x bar minus e is less than mu. Mu is a population mean, and this is less than x bar plus an e. So that's part of the formula again. The other part of the formula is going to be e equals, and then either we need to know that we need to use z sub alpha over 2 or t sub alpha over 2. So in order to determine whether it's going to be t or z, we have to know if the population standard deviation is known or if the population standard deviation is unknown. So based on the problem, we know that the ages of these 23 applicants have a mean of 47 and a standard deviation of 7.2. So this standard deviation is not population standard deviation, and the problem also doesn't say and from previous studies, the standard deviation is 7.2. This implies that this standard deviation is based on sample information. So again, if the problem doesn't say and a population standard deviation, or if it doesn't say and the standard deviation from the population is 7.2, or if it doesn't say and from previous studies or previous research, the standard deviation is 7.2, then this standard deviation is assumed to be sample. So because it's sample standard deviation, the formula we're going to use for the margin of error is t sub alpha over 2 times square root of s squared over an n. So if we were using t distribution, that means a sample standard deviation is the one that was given to us in the problem. So what we have to do now, or what we should do now, is write out the information that's known. So here we know that the ages of 23 applicants, that means n, and then the mean is 47, that means x bar, and then standard deviation is 7.2, that means s. So what I would suggest, instead of going to the problem and extracting information from the problem, and then matching it to the variables, I would suggest that you take the variables that you need based on the formula and then match it to the numbers that are given to us in the problem. So for example, in order to find this margin of error, I'm going to need s or s squared, which means sample variance. In this problem, they gave me sample standard deviation. So extract the s. S is equal to 7.2. And then n is equal to the sample size. N is equal to 23 because there's 23 applicants. So the sample size is 23. We're going to need t, but let's wait on this one for a second. And then we need x bar for this part of the formula. So extract x bar equals, and x bar represents the mean, sample mean, and the sample mean is 47. So extract the 47. Then again, we need t sub alpha over 2. So in order to find t sub alpha over 2, we're going to draw that t distribution. And the t distribution kind of looks like the normal distribution. And then for when determining the t distribution value or the critical value, you're going to be basing that off of the confidence. So this is 95% confidence. If it's 95% confidence, 95% goes in the middle of the distribution. Then what we're going to do is we're going to find the area on the outside of this distribution. So find the area on the outside. If the middle is 95%, the rest of this is 100% minus 95%, because the whole picture would be considered 100%. And if the middle is 95%, the rest of this as a whole is 5%. So we can say alpha is equal to 5%. 5% is the same thing as 0.05. So all I'm doing is rewriting it as a decimal. And if the outside is 5%, that means that the one tail is half of this. So half of 0.05, which is alpha over 2, means 0.05 divided by 2. So if you actually divide it, you get 0.025 for each of the tails. So this is 0.025. So there's two options here. When you go to the t-distribution table, what you can do is you can go and look up the area under one tail of 0.025, or you can look up the area under two tails of 0.05. And then based off of that, you can find the t sub alpha over 2 and the negative of that t sub alpha over 2. So let's go ahead and take a look at the t-distribution table. So in the t-distribution table, you'll see the area under two tails is 0.01, or if you go under the area under one tail, it's 0.0005. And that's true for when alpha is equal to 0.01. In our case, alpha was equal to 0.05, so this is a number that we're going to need, and the area under one tail would be 0.0025. So if you notice on the table, it also asks us for degrees of freedom, and for degrees of freedom, we're going to take n minus 1. So let's go back to our picture here, and degrees of freedom, let's go ahead and write down degrees of freedom is n minus 1. So this is a formula that you should memorize. This is equal to sample size, which is 23, minus 1, so that gives me back 22. So going back to the table in a second, I'm going to need alpha equals 0.05 degrees of freedom of 22. So alpha equals 0.05 and degrees of freedom of 22. So if you go down and you go across, you're going to get a critical value of 2.074. So this is a number that we're going to use as t sub alpha over 2. So 2.074. So this t sub alpha over 2 is equal to 2.074. So this is a number again that we're going to use for this value in the margin of error. Now that we have all of the values that we need, so we need the S, we needed sample size, we needed mean, and we also needed the t sub alpha over 2, we can take these numbers and we can plug them into our formulas. By the way, if I go back to this picture that I drew, this is going to be, this value on the right side would be that 2.074, and this would be the negative 2.074. You don't really need the negative in terms of this formula, but it will be useful if you draw this picture along with these values, the negative and the positive, so that when you get to chapter 8, we just build on this part on chapter 8. So let's go back to the formula. So we know that E, the margin of error, is equal to t sub alpha over 2 times square root of s squared over n. So then plug in our values. So t sub alpha over 2 is 2.074 times the square root of s squared. S is equal to 7.2. And then you square it, divided by n. N is equal to 23, so divided by 23. Then you plug all of this into the calculator. So going to the calculator, you get 2.074 times the square root, so second, and then hit the square root of 7.2, and then squared, divided by 23. And this gives us back a 3.1137. So this margin of error equals 3.1137. So in the textbook, it gives you some rounding rules. Just go ahead and use 4 numbers after the decimal, just to be consistent. These values that you find, the critical values, just go based off of what you see on the table. So if you see 3 numbers after the decimal, just go ahead and copy that whole number down. So from the table, copy it down, and then for any kind of calculations, use the 4 numbers after the decimal. And then what we're going to do is we're going to find the confidence limit. So x bar minus an e and x bar plus an e. So x bar minus e is going to be 47 minus e, which is 3.1137. And then we're going to calculate this. X bar plus an e is going to be equal to 47 plus a 3.1137. And then you calculate each of them. So 47 minus, and then you can go up if you have the newer calculators and just make sure that you select and hit enter. Or you can actually just type it out with 4 numbers after the decimal, and you get 43.8863 if I use 4 numbers after the decimal. So 43.8863. And then for the second one, for x bar plus an e, you can either do the same thing, actually not the same thing, but you can go up twice till you select the expression that we're going to go and change and put a plus sign. Hit enter, and then you can go back until you get to that minus, and instead of the minus, you would just put a plus. So you would put a plus, hit enter, and you get 50.1137. So this is 50.1137. Then when you're writing your answer, you have to write it as a confidence interval. So again, you can either write it in this form with interval notation, or you can write it in this form, which is inequality notation. Notice that with the interval notation, there's no brackets. It's always going to be parentheses with a comma in between. And in the inequality notation, you're always going to have your population parameter. This population parameter is going to be based on what you're looking for. So here we were looking for the confidence interval. This should say interval, by the way, not level. So confidence interval for the average age. Let me change that real quick. So find a 95% confidence interval for the average age. So this confidence interval is for the average or mean. So the mean would be mu. And then again, you could write it in either one of these forms. So 43.8863, comma 50.1137 with parentheses around it, or you can write it with inequality. So 43.8863 is less than mu is less than 50.1137. So this would be your confidence interval, any one of these two. And if you wanted to interpret, you could say we are 95% confident that the interval from 43.8863 to 50.1137 actually contains the population mean age of applicants who were unsuccessful in winning promotion.